Hi everyone, I am Dr. Kumari, working as an Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. So today in this video, I am going to discuss about Bernoulli's differential equations. So what we are going to learn in this video is here, what is Bernoulli's differential equation, what is the form of the Bernoulli's equation, and what is the procedure we are going to follow to solve the Bernoulli's differential equations. So by using that procedure, I am going to discuss some more examples here. So first of all, what is the Bernoulli's equation and what is this form we are going to see here? An equation of the form dy by dx plus py equal to qy power n. So here if you are having the form dy by dx plus py equal to qy power n, then we can say that this is the Bernoulli's differential equation. Here p and q are the functions of x. So this form is called Bernoulli's differential equation. So after identifying the form, what is the working rule? Otherwise, what is the procedure we are going to see here to solve the Bernoulli's differential equation? So here first we are taking the one condition. So based on the n value, we are going to discuss the cases here. If you are having n equal to 1, that means here the equation is dy by dx plus py equal to q into y power n. So based on this power value, we are going to discuss and we are going to decide about the solution. So here if n value is 1, then this equation becomes dy by dx plus py equal to q into y. Now dy by dx plus py minus qy equal to 0 here. So now finally dy by dx, and taking the y common here, p minus q into y equal to 0. So now I am taking here dy by dx equal to minus p minus q into y. So now I am taking dy by dy equal to minus p minus q into dx. So now I can write this equation as dy by dy plus p minus q into x dx is equal to 0. Now I can integrate this equation, integral dy by dy plus integral p minus q into dx equal to some constant. So this is the procedure by using the method variable separation. So variable separable method we can use if n value is 1. If n value is 1. So if n value is not equal to 1. So if n value is not equal to 1, then what will be happen here? We can observe. So if n not equal to 1, then divide the given equation with y power n. What is the first step we have to do? We have to first of all given equation is dy by dx plus p of x into y equal to q into y power n. So what is the equation? Dy by dx plus py equal to q into y power n. So here, what is the first step we are going to do here? First, divide the given equation by y power n. So, 1 by y power n dy by dx plus p of x into y by y power n equal to q into y power n by y power n. So, y power n will be cancelled, and here y power minus n into dy by dx plus p of x into y power 1 minus n equal to q. That is only this equation. After doing this simplification, we are getting this equation form. So this is the first step. First step, we are dividing with y power n. So in the second step, we are substituting some value here. So this value I am substituting with some other value. So here I am taking y power 1 minus n equal to u. So here I am taking y power 1 minus n equal to u. Otherwise, we can take y power 1 minus n equal to v also, any variable. This one y power 1 minus n equal to u, or we can take y power 1 minus n equal to v. So, if you are taking y power 1 minus n equal to u, so first I am differentiating here 1 minus n into y power 1 minus n minus 1 dy by dx is equal to du by dx. Here I am doing the differentiation with respect to x. Then finally what I am getting here, 1 minus n into y power minus n dy by dx is equal to du by dx. So finally y power minus n dy by dx equal to 1 by 1 minus n into du by dx. 1 minus n into du by dx. That value we can observe here. This is only we are having. So otherwise if you are replacing u, this is the value. So now we are going to replace this one in the equation 1. Then what happened here we can observe. So now y power minus n into dy by dx is equal to du by dx. Now I am replacing this one in the equation 1. So in place of y power minus n dy by dx, I can replace du by dx plus p of x into y power 1 minus n I am taking as u equal to q. So now this is the equation we are going to solve. So now this is in the linear form. So what is the next procedure we can follow? First we have to calculate the integrating factor, then the general solution. So what is the integrating factor? E power integral. So what is the value we are having? Based on that we can calculate. So we can observe here. So here in place of du by dx we are having one more term, that is 1 by 1 minus n. So that value here 1 by 1 minus n, here I am having 1 by 1 minus n, and here also we are having 1 minus n. Here also we are having 1 minus n. So finally what is this equation? So in this equation 1 by 1 minus n into du by dx plus p of x into u equal to q. Now I am sending this 1 minus x, I am multiplying with 1 minus x now. So du by dx plus p of x into 1 minus n into u equal to q into 1 minus n. Q into 1 minus n. Now this is the linear differential equation. So what is the integrating factor? Integrating factor is e power integral p into 1 minus n into dx. This is the integrating factor. So what is the general solution we can observe here? So this is the integrating factor, e power integral 1 minus n into p dx. After that, what is the general solution? So complete primitive means nothing but this is the general solution. Both are same. So general solution or complete primitive is given by v into, otherwise if you want you can write u into integral 1 minus n into p into dx, that means integrating factor. You can write here u into integrating factor is equal to integral q into, in place of q we are having q into 1 minus n. So into integrating factor into dx plus. So what is the integrating factor here? E power integral 1 minus n into p dx is equal to integral q into 1 minus n into e power integral 1 minus n to p dx into dx plus. So this is our general solution and this is our integrating factor. So here in this procedure, what are the steps we done to solve the Bernoulli's equation? First, we are divide with y power n. After that, we are converting into linear differential equation. After that, in the third step, we are going to find the integrating factor. In the next step, last step, we are finding the general solution. So this is the procedure we are going to follow here to solve the Bernoulli's differential equation. So now we are moving to example problems to get the proper clarity about the procedure. So here solve x into dy by dx plus y equal to x cube into y power x. So what is the given equation? X into dy by dx plus y equal to x cube y power 6. This is the given equation. Now first I have to simplify this equation into the form of Bernoulli's equation. So that's why dy by dx, I am dividing with x first. So y by x is equal to x cube y power 6 by x. So here x will be cancelled. Finally I am getting x square y power 6. So this is, I am comparing with the Bernoulli's equation form, dy by dx plus p of x into y equal to q into y power n. So when I am comparing with this Bernoulli's equation form, we are having here p of x equal to 1 by x and q of x equal to x square, and here y power n is there, so n value is 6. These are the three values after comparison with the differential equation, Bernoulli's differential equation. So after taking these values, what is the first step we are going to do? First step, what is the first step? First step, we have to divide with y power n. So here what is the y power n? We are having y power 6. So that means divide y power 6, divide with y power 6. So here the given equation is dy by dx plus 1 by x into y equal to x square into y power 6. Now I am going to divide with y power 6. So 1 by y power 6 dy by dx plus 1 by x into y by y power 6 equal to x square into y power 6 by y power 6. So y power 6, y power 6 will be cancelled. Here y power minus 6 into dy by dx plus 1 by x into y power 1 minus 6 is equal to x square. Now I am going to take one value as a substitute value. So here I am taking y power 1 minus 6 is equal to something. That means this is 1 y power minus 5 equal to u. So here y power minus 5 is nothing but 1 by y power 5. So what I have to do after taking this substitution, I have to differentiate this value. So y power minus 5 is equal to u. Now I am differentiating this one with respect to x. So minus 5 into y power minus 6 dy by dx is equal to du by dx. So that means this value, this is minus 5 by y power 6 dy by dx is equal to du by dx. So here this is y power minus 6 dy by dx is equal to minus 1 by 5 du by dx. That means in place of y power minus 6 dy by dx, I can replace minus 1 by 5 du by dx in the given equation. So what is the given equation we can observe here? Dy by dx. So y power minus 6 into dy by dx plus 1 by x into y power 1 minus 6 is equal to x square. So this is the equation. Now I am going to substitute the value of y power minus 6 dy by dx. So now this is minus 1 by 5 du by dx plus next 1 by x into here y power 1 minus 6 is nothing but u is equal to x square. Now I am sending this one minus 1 by 5 to the left side. So then equation becomes du by dx minus 5 by x into u equal to minus 5x square. So here I am multiplying with minus 5. So finally I get the equation here du by dx minus 5 by x into u equal to minus 5x square. This is the linear differential equation in u. So here what is the procedure we are doing? We are converting the Bernoulli's equation into linear differential equation to get the general solution. So we already converted into the linear differential equation form. So what is the procedure now? We are going to calculate the integrating factor, and after that we are going to calculate the general solution. So what is the integrating factor? So integrating factor equal to e power integral p of x dx. So first of all, what is the p of x from this equation? That is minus 5 by x. What is the q of x here? Q of x equal to minus 5x square. So now here I am going to replace that value. So e power integral, what is the p of x value? Minus 5 by x into dx, that's right. So here e power minus 5 is the constant. So integral 1 by x dx. So what is the value of integral 1 by x dx? That is log x. That is log x. So finally this value is e power log of x power minus 5. So log e base c is the 1. So finally this value is equal to 1 by x power 5. That means integrating factor value is 1 by x power 5. Integrating factor value is 1 by x power 5. So what is the last step we are going to do after calculating the integrating factor? Yes, right. So now we are going to calculate the general solution. So general solution is u into integrating factor equal to integral q of x into integrating factor into dx plus c. So u into what is the integrating factor? Already we got 1 by x power 5 is equal to integral. What is the q of x value? Q of x value is minus 5x square. I am replacing here. Minus 5 into x square. 1 by x power 5 is the integrating factor into dx plus c. So now minus 5 is the constant. Integral x square and x square will be cancelled. Here I am going to get 1 by x cube dx plus. So now here what I am getting the value, we can simplify here u into 1 by x power 5 equal to this one minus 5 is the constant. Integral x power minus 3 is minus 3 plus 1 by minus 3 plus 1. So already we know the formula integral x power n is x power n plus 1 by n plus 1. So when you are solving the problem, you should have the basic definitions and basic formulas. Then only you can solve the problem. So that means basic definitions means differentiation formulas and integration formulas. So what are the formulas included in this solution? The whole formulas, if you will know, then only you can solve this type of problems. That's why you should get the idea about the formulas and basic definitions. So here minus 5 into x power minus 3 plus 1 by minus 3 plus 1 plus c. So u into 1 by x power 5 equal to minus 5 into x power minus 2 by minus 2 plus c. So finally in the last stage we have to replace the by u value also. What is the u? U is 1 by y power 6 into 1 by x power 5 equal to, here minus minus will be cancelled. So for this 5 by 2 and 1 by x square plus c. So this is our complete primitive or general solution of the given equation. So I hope we understand this procedure. So I am moving with one more example here. You can observe the equation. Solve secant square x dy by dx plus 2x tan y equal to x cube. So here the solution, writing the given equation is, what is the given equation? Secant square y dy by dx plus 2x tan y equal to x cube. Now I am taking this value as here. What is the procedure we are going to follow for the Bernoulli's equation? First we have to check about the Bernoulli's form is there or not. So if you are checked with that, dy by dx plus p of x into y equal to q into y power n. So here dy by dx is there, p of x into y is there. So here q into y power n. So here y power n is not there, but we can say that this one is y power 0. So that means here one step is missed. So we no need to divide with y power n. So what is the steps we are going to follow for the solution of the Bernoulli's differential equation? First step, we are going to divide with y power n value. So here y power n value is not there. That means no need to divide with the y power n. So remaining procedure as it is we have to do. So here I am taking the next step, substitute value. I have to take one substitution value. Here take tan y equal to u. Take tan y equal to u. So secant square y dy by dx. I am doing differentiation with respect to x. So secant square y dy by dx equal to du by dx. Du by dx. So now I am going to replace this value in the equation 1. So then equation 1 becomes du by dx plus 2x into u equal to x cube. Now it is in the linear differential equation form. So that means second step also completed. What is the third step? So we should have the linear differential equation form. So what is the step after getting the linear differential equation form? We have to calculate integrating factor. In the final step, we are going to calculate general solution. So here we are going to calculate the integrating factor. What is the integrating factor? Integrating factor equal to e power integral p of x dx. So what is the p of x value here? P of x value is 2x. So e power 2 integral x dx. That means e power 2 into integral x is x square by 2. So 2 will be cancelled. Finally, this is e power x square. So integrating factor is e power x square. So integrating factor is e power x square. So after completion of the integrating factor, what we have to do? We are going to calculate the general solution. So what is the general solution? So general solution equal to u into integrating factor equal to integral q of x into integrating factor into dx plus c. This is the formula for the general solution. So u into what is the integrating factor? E power x square equal to integral. What is the q of x value? Q of x value is x cube. So x cube into here. This is du by dx plus 2x into u equal to x cube. So x cube into what is integrating factor? E power x square into dx plus c. So now I am using substitution method to integrate this function. So I am taking here x square equal to d. So then 2x dx equal to dt. So x dx equal to dt by 2. I need to take here. So here integral, I am writing this one as x e power x square. Okay, x square into x dx plus c. So here x square in place of x square, I need to replace the t value. So e power t, and here also t, and in place of x dx, I can replace gt by 2 plus c. Now I got the value here. U into e power x square equal to integral t into e power t dt by 2. So now I can solve this equation. So integral 1 by 2 is the constant I am taking. Separately I am calculating this value now. So 1 by 2 is the constant, integral t into e power t dt. So that means I am going to follow integral u into e power. So 1 by 2 into t integral e power t minus integral derivative of t is 1. Integral e power t is e power t into dt. So finally what is this value? 1 by 2 into t into e power t is e power t minus e power t. This value I am going to substitute here. So that is 1 by 2 into e power t into t minus 1 plus c. So now in the next step I am going to replace the x square value because t is nothing but x square. That is what we can observe here. General solution is e power integral x cube into e power x square dx. So in place of t we are replacing x square. So 1 by 2 here. So 1 by 2 e power t is in place of t we are replacing the x square. So here t minus 1 means here x square minus 1 plus c. So what is the u value here? U value is u into. So u into e power x square equal to, this value is 1 by 2 into e power t into e power t, t minus 1 plus c. So we are replacing x square. So you have to replace the u value also. What is the u value? U value is tan y. So tan y into e power x square equal to 1 by 2 into e power x square into x square minus 1 plus c. This is our final general solution. With one more example here. Solve y plus 2 into dy by dx is equal to y cube into x minus 1. So what is the given equation here? Y plus 2 into dy by dx equal to y cube into x minus 1. So now I am writing here into the form of dy by dx. So dy by dx plus 1 by 2 into y is equal to 1 by 2 into x minus 1 into y cube. So this is the Bernoulli's equation form. So here first we have to divide with y power n. So nothing but that value is y cube. So here 1 by y cube dy by dx plus 1 by 2 into y power 1 minus 3 equal to 1 by 2 into x minus 1. So now I am taking y power 1 minus 3 equal to sum u r p. So that means y power minus 2 equal to v. So when you are differentiating here, minus 2 into y power minus 3 into dy by dx is equal to du by dx or dv by dx. That I am going to replace here. Minus 1 by 2 into y cube dv by dx plus 1 by 2 into y 1 by 2 into x minus 1 into y cube. So finally, after replacing this value, I am getting here dv by dx minus 1 by 1 into v equal to minus x minus 1. So now I am having the p of x value. What is the p of x value here? Minus 1. What is the q of x value here? That is 1 minus x. By using these two values, I am going to calculate the integrating factor and the general solution. You can observe here. So this is the linear equation. So integrating factor is e power integral minus 1 into dx. So e power integral minus integral dx is x. So this is the integrating factor. So here after that, what is the general solution? So general solution is u into integrating factor is equal to integral q into integrating factor into dx plus c. So here u into e power minus x is equal to integral 1 minus x into e power minus x into dx plus c. So now u into e power minus x. So here I am going to multiply with the constant. So this is integral e power minus x dx minus integral x into e power minus x dx plus c. So finally this is u into e power minus x equal to integral e power minus x is e power minus x by 1. And here for this value we are going to use the integral by parts. So that's why separately I am calculating here integral x into e power minus x. So here x integral e power minus x minus integral f dash x, that means x dash value is 1. So integral e power minus x dx whole dx. Now this value is x into e power minus x by minus 1 minus here e power minus x by minus 1. So minus minus plus integral e power minus x dx. So finally what I am getting here, u into e power minus x equal to integral e power x value is e power minus x by minus 1 minus integral x into e power x value is, I am writing here, minus x into e power minus x this value plus integral e power minus x dx. So what finally I am getting here, minus e power minus x minus x into e power minus x. Here minus e power minus x by 1. So this is the final solution. So in place of u, what is the u value I am taking here? U value is here y power minus 2. So here y power minus 2, that means 1 by y square into e power minus x equal to. This is the general solution for this given Bernoulli's differential equation. We can observe one more example here to get the better clarity about this type of problems. So you can see here, solve 1 minus x square into dy by dx plus xy equal to y cube into sine inverse x. First given equation is 1 minus x square into dy by dx plus xy is equal to y cube into sine inverse x. Now I am going to convert this equation into the Bernoulli's equation form. So that's why first dividing with 1 minus x square. So dy by dx plus x by 1 minus x square into y is equal to y cube into sine inverse x by 1 minus x square. So now I got the value here. So when I am comparing with the Bernoulli's equation, what is the Bernoulli's equation? Dy by dx plus p of x into y is equal to q into y power n. So what is the p of x value? P of x value is x by 1 minus x square. What is the q of x value? Q of x value equal to sine inverse x by 1 minus x square. And here y power n is there, that is nothing but here n value is 3. N is 3. Now what is the first step I have to do? First step, divide with y power n. So here y cube. So divide the equation 1 with y power n. So here y power n is 3. So dy by dx means 1 by y cube dy by dx plus x by 1 minus x square y by y cube is equal to sine inverse x by 1 minus x square y cube by y cube. So y cube will be cancelled. So here y power minus 3 dy by dx plus x by 1 minus x square y power 1 minus 3 is equal to sine inverse x by 1 minus x square. This is the equation form. Okay, so now I have to take one substitute value. So let y power 1 minus 3 equal to u, nothing but y power minus 2 equal to u. So in the next step, if you are taking y power minus 2 equal to u means here I am going to do the differentiation for this minus 2 into y power minus 3 into dy by dx is equal to du by dx. So finally this is minus 2 by y cube into dy by dx is equal to du by dx. So finally y power minus 3 into dy by dx is equal to minus 1 by 2 into du by dx. This value I am going to substitute in the equation 1. So what is the equation 1 here? This one y power minus n. So here y power minus 3 dy by dx, y power minus 3 dy by dx plus x by 1 minus x square into y power 1 minus 3 is equal to sine inverse x by 1 minus x square. So in place of y power minus 3 dy by dx, I can replace minus 1 by 2 du by dx. So minus 1 by 2 du by dx plus x by 1 minus x square into u equal to sin inverse x by 1 minus x square. So here du by dx equal to, du by dx plus here I am multiplying with minus 2. So that means here I am getting minus 2x by 1 minus x square into u equal to minus 2 into sin inverse x by 1 minus x square. Now what is the p value? So p of x equal to minus 2x by 1 minus x square. P of x value, that is minus 2 into sin inverse x by 1 minus x square. That is only we can observe here. This is p of x and this is p of x. Now this is the linear differential equation in U. So this is the linear differential equation in U. So then we have to do the two steps. First we have to calculate the integrating factor. After then general solution. So what is the integrating factor? Integrating factor equal to e power integral p of x dx. That is only we wrote here. E power integral p of x dx. So e power minus integral 2x by 1 minus x square dx. So here f of x derivative is 2x. So that derivative is there. So we can write here by using the formula integral f dash of x by f of x dx. We can write it as log fx. Log fx. So e power log, in place of fx we are having 1 minus x square. So e power log 1 minus x square. So this will become log 1 minus x square into log e base e. So finally this is 1 minus x square. So this is the integrating factor we got here. So what is the integrating factor? Finally that value is 1 minus x square, already we calculated. Now we are going to find the general solution. What is the general solution? U into integrating factor equal to integral u into integrating factor into dx plus c. So now u into what is integrating factor here? 1 minus x square is equal to integral. What is the q value? Q value is minus 2 into sin inverse x by 1 minus x square into integrating factor is 1 minus x square into dx plus c. So 1 minus x square will be cancelled. So finally here minus 2 integral sin inverse x dx plus c. So u into 1 minus x square. Now we are going to calculate the integral sin inverse x dx. So here u into 1 minus x square equal to integral minus 2 into, so here minus 2 integral sin inverse x dx plus c. So actually we don't have the integration formula for the sin inverse x. So that's why we are going to use the integration by part, that is integral u into v. So here we are taking u value is sin inverse x and v value is 1. Based on that we are writing here. So minus 2 here sin inverse x integral dx according to the formula. What is the formula for the integral u into v? So u integral v minus integral u dash into integral v whole dv. So based on this formula we are writing here. So sin inverse x integral dx minus integral sin inverse x derivative is 1 by square root 1 minus x square into here that value integral dx is x into dx. So finally minus 2 into, so here integral dx is x, so x sin inverse x minus here x, and when you are taking here substitution method we are getting here. So 1 minus x square derivative is, if you take 1 minus x square equal to t square, then minus 2x dx equal to 2t dt. So 2 will be cancelled, 2 will be cancelled, x dx equal to minus t dt. So already t is there. So here in place of this integral 1 by t and minus x dx we are writing, in place of x dx we are writing t into dt. So t will be cancelled. So minus 2 x sin inverse x plus here integral dt is t. plus c. So what is the t value? T value is square root of t. So minus 2x sine inverse x plus square root 1 minus x square plus c. That is only we got here. So u into 1 minus x square equal to minus 2 into x sine inverse x plus square root 1 minus x square plus c. So this is our general solution. In place of u, we have to replace that value also. That is 1 by y square into 1 minus x square equal to minus 2 into x sine inverse x plus square root 1 minus x square plus c. This is our general solution of the given differential equation. So this is the procedure we are following to solve the Bernoulli's differential equations. Just I want to recall the steps. The first step, we are divide with y power n. The second step, we are converting given equation into linear differential equation. So after that, we are calculating the integrating factor. The fourth step, we are calculating the general solution. These are the 4 steps we are following here to solve the Bernoulli's differential equation. I hope you got the better clarity about these Bernoulli's differential equations. So here, please take some more examples to solve and to practice more. So see here, these are the reference textbooks I used here for this Bernoulli's differential equation. Please collect the problems and basic forms from these textbooks, and based on that you can get more clarity and you can have the better idea about the solving of Bernoulli's differential equation. So higher engineering mathematics written by B.S. Gravel, and one more textbook is there, a textbook of engineering mathematics written by N.P. Bala and Manish Goyal, and higher engineering mathematics written by P.V. Ramana, and engineering mathematics written by T.K.V. Iyengar. These are the reference textbooks you can use to have the idea about these ordinary differential equations, especially about the Bernoulli's differential equation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.